Assalamualaikum. Hi everyone. Okay, in this video we will look one example. The first example related to the valve flow characteristic which we have learned in the previous video. And this example we will look into some calculations related to the equal percentage formula, which is given by Q equals to Q mean R power of S over S max. Okay, let's look into this example. The maximum flow rate through a control valve with an equal percentage characteristic is given by 10 meter cube per hour. If the valve has a turn down of 50:1 ratio, and is subjected to a constant differential pressure, using the above equation, what quantity will pass through the valve with the lift of 40%, 50%, and then 60%. So here we need to do some calculations. Okay, let's look on how to calculate. So we are given the max flow rate, we call it Q max, equals to 10 meter cube per hour, and then the valve turn or rangeability is given by R equals to 50:1. Yeah. The constant different pressure is assumed, which means we can use this formula. Okay, so for you maybe not familiar with this, the way I type this equation, Q equals to Q mean, Q equals to Q mean multiplied with R, I'm using asterisk symbol, multiplied with R. R is to the power of S over S max. Yeah, so R, by using hat symbol, R to the power of S over S max, similar to this equation. Okay, so by using this equation, we are going to find what is the flow rate Q. Okay, when the lift is 40%, 50%, and 60%. So let's look at the solution. So first, we need to understand what does lift of 40% means. Yeah. So going back words in to our previous slides, S equivalent to stern position, S max is the maximum stern position. Usually this value will be given or we need to calculate. So the valve lift of 40% means the S max multiplied 100% is equivalent to 40%, which means without the percent, S over S max is equivalent to 0.4. Okay, so meaning that if we are looking to find the valve lift of 40%, we need to understand that the ratio S over S max equivalent is 0.4. If the valve lift is 50%, meaning that this ratio is 0.5, and so on. Okay, now we are going to use this equation to calculate the value of Q. Okay, but we are still missing with the value of Q mean. In this equation we need Q mean. So how to find Q mean? Okay, so since we are given the valve turn down rangeability R equals to 50:1, means that we already given R equals to 50, meaning that R, which is the ratio Q max over Q mean, is 50. So now here we can calculate what is Q min, since we already know the Q max. Okay, so given that Q max equivalent to 10 meter cube, therefore Q min is equivalent to Q max over 50, 10 over 50, and this is the value of Q min, 0.2 meter cube per hour. So now let's look on how to calculate Q 40%. So by using this equation, okay, so Q min is 0.2 multiplied by 50, the rangeability, to the power of 0.4, which is the S over S max. Okay, if you continue with calculation, you will get this answer, which is 0.9564. Okay, so that's the answer. So you need to proceed with Q 50% and Q 60%. So if you look at the table given in the slide, you can compare the value. See, 40% lift is equivalent to 0.96, yeah, rounded up to 2 decimal point. Okay,